Okay guys, welcome back. Basic electricity number 111. Okay, normal operations. Normal operations. Normal operations. The presence of many small amounts of potassium carbonate deposits on the top of the nickel-cadmium battery cells is an indication of normal operations. Normal operations. The presence of any small potassium carbonate deposits on top of the nickel-cadmium battery cells in a service is an indication of normal operations. Normal operations. Okay, number 112. Contamination of both types of batteries. Contaminations of both types of batteries. When it is likely to result of servicing and charging nickel cadmium and lead acid batteries together in the same service area, you can't do that because contamination of both types of batteries. Contamination of both types of batteries. What is likely the result of servicing of charging and nickel cadmium and lead acid batteries together in the same servicing area? You're going to have contamination of both types of batteries. Okay, number 113. To completely charge a nickel cadmium battery, some gassing must take place. Thus, some of the water will be used. To completely charge a nickel cadmium battery, some gassing will take place. Thus, some of the water will be used. So, which of the following best describes the operational principle of a nickel cadmium battery as it is installed on the aircraft? Complete charged nickel cadmium batteries. Some gassing must take place, so some of the water will be used. Completely charged nickel cadmium battery, some gassing must take place, and some of the water will be used. Okay? Beautiful. Number 114. In a discharge condition. In a discharge condition, the electrolyte of a nickel cadmium battery is at its lowest point when it is at a discharge condition. Discharge condition. The electrolyte of a nickel cadmium battery is at its lowest point when it's at a discharge condition. Okay? 115. A fully charged condition. A fully charged condition. Electrolyte of a nickel cadmium battery is at its highest when the battery is fully charged. Fully charged condition. Fully charged condition. The electrolyte of a nickel cadmium battery is at its highest when the battery is in a fully charged condition. Fully charged condition. Excellent. Number 116. Depending upon its temperature and method used for charging. Depending on its temperature and methods used for charging. Depending on its temperature and methods used for charging. The end voltage of a 19-cell nickel cadmium battery measured while still on charge depends upon its temperature and the methods used for charging. Depends on its temperature and method used for charging. Okay? Number 117. The electrolyte becomes absorbent into plates. The electrolyte becomes absorbent into plates. The electrolyte becomes absorbent into plates. During the discharge, nickel cadmium batteries will show a lower liquid level than when a full charge because the electrolyte becomes absorbent into the plates. The electrolyte becomes absorbent into the plates. Okay, number 18. By a measured discharge. By a measured discharge. By a measured discharge. How can the state of the art of a nickel cadmium battery be determined? The state of charge, of a nickel cadmium battery be determined by a measured distance. By a measured distance. Okay? How can the state of charge of a nickel cadmium battery be determined by a measured distance? Beautiful. Number 19. 119. Excessive spewing is likely to occur during the charging cycle. Excessive spewing is likely to occur during the charging cycle. What may result if water is added to a nickel cadmium battery when it's not fully charged? Excessive spewing is likely to occur during the charging cycle. Excessive spewing is likely to occur during the charging cycle. What may result if water is added to a nickel cadmium battery when it's not fully charged? Excessive spewing is likely to occur during charging cycles. Okay? Excellent. Number 120, causes a decrease in internal resistance. Causes a decrease in internal resistance. Causes a decrease in internal resistance. In a nickel-cadmium batteries, a rise in temperature cells causes a decrease in internal resistance. Causes a decrease in internal resistance. Nickel-cadmium batteries, a rise in cell temperature causes a distance in internal resistance. Number 121, basic electricity. Low internal resistance intensified by high cell temperatures and high current discharge rate in a constant potential voltage charging system. Low internal resistance intensified by high cell temperatures and high current discharge rate in a constant potential voltage charging system. Which of the following best describes the contributing factors to a thermal runaway in a nickel-cadmium battery installed on the aircraft? It's a low internal resistance intensified by high cell temperatures and high current discharge or charge rate in a constant potential voltage charging system. Okay? Number 122. Towards the end of the charging cycle. Towards the end of a charging cycle. When a charging current is applied to a nickel-cadmium battery, the cell emits a gas. Towards the end of the charging cycle. Towards the end of a charging cycle. When charging current is applied to a nickel-cadmium battery, the cells emit a gas towards the end of the charging cycle. Okay? Excellent. Take a quick break, and I'll talk to you soon.